Good morning, students. How are you? Welcome back to the science class. Last class, we started our fourth lesson, structure of the atom. Then we discussed about charged particles matter. What are the charged particles in matter? Electrons, protons, neutrons. Electrons are negatively charged, protons are positively charged, neutrons have no charge. Then discovery of subatomic particles. In 1900, J.J. Thomson discovered the presence of the negatively charged particles called electrons. In 1886, E. Goldstein discovered new radiation in gas discharge called the canal rays. These rays were positively charged. Later, these charged particles are called protons. In 1932, Chadwick discovered the presence of particles having no charge in an atom called neutrons. Next, structure of the atom, Thomson's model of an atom, Rutherford's model of an atom. Then we conclude up to Rutherford's alpha scattering experiment. What is Rutherford model of an atom? An atom has a positively charged nucleus as its center, and most of the mass of the atom is in the nucleus. The electrons revolve around the nucleus in different orbits. The size of the nucleus is very small compared to the size of the atom. Today we are going to discuss about defects of Rutherford's model of the atom. Defects of Rutherford model of the atom. The revolution of the electron in a circular orbit is not expected to be stable. We studied that the atoms are stable in nature. Here, the defect of Rutherford's model. What is the demerit? Defects means demerit. Defect of Rutherford model. Any particle in a circular orbit would undergo acceleration. During acceleration, the charged particle would radiate energy. So the revolving electrons would lose energy and fall into the nucleus, and atom would be unstable. We know that atoms are stable in nature. Here, according to Rutherford's model of an atom, he said the atoms are unstable. So it is one of the defects of Rutherford model. Here, see here two pictures are given. The plus point, that is positively charged protons, is found inside the atom in the nucleus. The negatively charged electrons in orbit. The electrons are revolving around the orbit. Electrons are negatively charged, positively charged nucleus, it contains protons. While the electrons revolving in the discrete orbits, the electrons do not radiate energy. When the electrons revolving, rotating around the orbit, the electrons do not radiate energy. The electrons won't get any energy. When the electrons revolving around the orbit, the charged particle gets energy. Which one is the charged particle? Protons are the charged particle. So the protons again gets charged. But the electrons, when it is revolving, during revolution, it increases the acceleration. What does it mean acceleration? The speed. When the speed of revolution increases, the electron will loses energy. That energy will charge in the positively charged particles, in the protons. The protons get more energy, but electrons will lose energy. So at last, according to Rutherford, he is saying the When the electron will lose the energy, it will fall into the nucleus, so the atom become unstable in nature. Actually, the atoms are stable in nature. This is one of the defect of Rutherford's model of the atom. The next one is Bohr's model of atom. In order to overcome the objections raised against Rutherford's model of the atom, Niels Bohr put forward the following postulates about the model of an atom. Only certain special orbits known as discrete orbits of electrons are allowed inside the atom. An atom has a positively charged nucleus at its center. Most of the mass of the atom is in the nucleus. The electrons revolve around the nucleus in special orbit called discrete orbit. See here one picture is there. The center plus point, plus is the positive charged nucleus. It contains protons. Around the plus point, the number of orbits are there. Orbits, revolving point. The orbits are number 1, 2, 3, 4. Here total how many orbits they given? 4 orbits. In this, what is the function of these orbits? The electrons are revolving through these orbits. Then this first orbit is named as K. Each orbit is called as shells. These orbits are called as shells. The first orbit is known as K shell. Second orbit is called L shell. Third one is called M shell. Fourth one is called N shell. L, K, L, M, N. The electrons are revolving around these shells. First shell is K, second L, third one M, and fourth one is N. The next one is how are electrons distributed in different orbit or shells? The distribution of electrons in different shells. The distribution of electrons in the different shells was suggested by Bohr and Bury. The following are the rules for filling the electrons in the different shell. Now you know what is shell. The shells found around the nucleus of an atom. The shell is represented as in the number wise 1, 2, 3, 4 and the letter wise K, L, M, N. The maximum number of electrons in a shell is given by the formula 2n square. Dear students, keep it in mind. The maximum number of electrons in a shell is given by the formula 2n square, where n is the number of the shell. Already last this one I show that number of shells we designated as 1, 2, 3. So n is the number of shell. So first shell, what is the first shell? K shell. In the K shell have how many electrons? How can we calculate? What is the formula for calculating the number of electrons? 2n square. In the first cell is in 2 into what is the number of the shell? K shell. What is the number? Number 1. So 2n square is equal to 2 into 1 square. First shell 1. Number of electrons 2 electrons. So in the first orbit should contain only 2 electrons. Second shell is designated L shell. What is the formula? 2n square. So 2 into second shell 2. 2 into 2 square. How many electrons? 8 electrons. The second orbit should have 8 electrons. The third shell, M shell, 2n square, 2 into 3 square, 2 into 3, 3, 18 electrons. The third orbit should contain 18 electrons. The next one is fourth shell, n shell. It can have 2n square, 2 into 4 square, 2 into 4, 4, 32 electrons. Like this, if the fifth shell means KLMNO. What is the name of the fifth shell? O shell. How can we calculate the fifth shell electron? 2n square equal to 2 into 5, 5 square. So 2 into 5 into 5. Like this we can calculate the number of electrons in an orbit. The maximum number of electrons that can be filled in the outermost shell is 8. The outermost shell should contain 8 electrons. The electron cannot be filled in the shell unless the inner shells are filled. If the inner shells are not filled, the first shell should contain 2. It should contain 2. If the first shell contain 1 or more than 2, means it is not, the shell can't, the atoms can't able to stable condition. So all the first shell should contain 2, the second shell 8, third 18, fourth 32. The outermost orbit should contain, for making an atom stable, the outermost shell should contain 8 electrons. Composition of the atom of the first 18 elements. See here in the table you can see the name of the element. 18 elements are there, their symbol, atomic number, how many protons are there, how many neutrons are there, number of electrons, the distribution of electrons in an orbit, everything we can see. What is the valency? Valency is the combining capacity of atom of an electron. Valence means the electrons present in the outermost shell of an atom are called valency electrons. Keep it in your mind. What is valency electrons? The electron present in the outermost shell of an atom are called valency electrons. Then here see this table. The name of the element hydrogen, symbol H, atomic number 1. In hydrogen only one protons are there, there is no neutron and only one new electrons, one proton and one electron. Then what is the electron arrangement in that orbit? In the center proton, around that only one orbit is there, K shell, first shell, K shell. How many electrons are there? Only one electron. So in the K shell, first orbit contain only one electron. So the valency electron is 1. What is valency electron? The electron which is present in the outermost shell of an atom. Then the next one, helium, He, atomic number 2, protons 2, neutrons 2, electrons 2. So the distribution of electron. The electrons, how many orbit will come? Only one orbit which revolve around the proton. So how many electrons are there? 2 electron. Valency means 0. What is the valency? 0. How it becomes 0? The first orbit, the last slide I showed that the first orbit should contain 2 electron. One formula we studied, 2n square. The first orbit means 2 into 1 square equal to 2 electron. The first orbit should contain 2 electron. So in the helium, the first orbit contain 2 electrons. There is no valency. Valence electrons 2. Lithium also atomic number 3. Number of protons 3. Number of neutrons 4. Number of electrons 3. Distribution of electrons, total 3 electrons are there. So how many orbit will come? 2 orbit. K and L, because the K shell total 3 electrons, the K shell 2, the L shell 1, L shell 1, total 3. So what is the valency? The outermost shell contains only one electron. That is the valency. Beryllium, Be, atomic number 4. What is atomic number? The number of proton and the number of electrons is the atomic number. Don't get confusion. Number of protons 4, number of neutrons 5, number of electrons 4. So distribution of shell, K and L shell. K shell should contain 2 electrons. 2 is there. Again L shell also 2. But what is the valency? Valency is the outermost shell. How much electrons we need? 8 electrons. The second orbit should contain 8 elements. Only 2 is there. So valence is the 2. Boron B, atomic number 5, proton 5, neutron 6, electron 5. Then distribution electron, first orbit K 2, second orbit 3. Valence is 3, the outermost shell. Carbon 6 C, atomic number 6, proton 6, neutron 6, electron 6. Then electron distribution, first orbit 2, second orbit 4. The valence is 4. Nitrogen, carbon, nitrogen symbol N, 7, atomic number 7, proton 7, neutron 7, electron. So electron distribution, first shell, K shell 2, L shell 5. Valency is 3. Valency is 3. How valency 3? In the 5 second shell 5 is there. Second shell need 3 more. So valence is 3. Then oxygen O, atomic number 8, proton 8, neutron 8, electron 8. Then the K shell contain 2, distribution, L shell 6, total 8 electron, 6. But the outermost shell need 2 more electron. So valence is 2. Then the next one, fluorine F9, atomic number 9, proton 10, neutron 9, electron 2, 7. First shell contain 2, second shell contain 7. The valency 1. Because the L shell need 8 electron but 7 is there. 1 more in the valency 1. Then neon Ne 10, 10, 10, 10. Atomic, proton, electron, everything is 10, 10, 10. Then the electron arrangement, first shell 2, second shell 8. The second shell, first shell also 2, second shell also 8. It is, so valence is 0. No more electrons can add in the second shell. Then sodium 11, atomic number 11, proton 12, neutron 11, electron. Then what is the distribution of electron? 2, first shell, second shell 8, 10, then third shell 1. Valence is the third one. 1 is the valency. The next one, magnesium Mg 12, 12, 12, 12, 12. The electron distribution 2, 8, 2. So the first second shell, the valence, the M shell contain 2. The valence is 2. This is the composition atom of the first 18 elements. See here the atomic structure of the first 18 elements. Hydrogen, the center, proton, 1 orbit is there. Hydrogen only 1 electron. So first orbit contain only 1. That is a K shell. Helium, 2 electrons are there. So first orbit contain 2 electrons. Lithium total 3 electrons are there. So first orbit contain 2. The second orbit here contain only 1 electron. Beryllium. Total 4 electrons are there. First orbit 2, second orbit 2. First orbit should contain 2. Boron. Total 5 electrons are there. First orbit 2. Remaining valence 3 is in the second orbit. Carbon. Total 6 electron is there. First 2. The 4 in the second orbit. Nitrogen. Total 7 electrons are there. First orbit 2, second orbit contain 5. So what is the valence electrons? 3 more electrons they need for filling the second orbit. So 3 is the valence. Oxygen 8. First orbit 2, second orbit 6. How many electrons needed for filling the second orbit? 2 more. Then it becomes 8. So 2 is the valence. Fluorine. Like this, see these pictures, everything. Fluorine 2, first orbit, the second orbit contain 7. Total 9 electrons. How many electrons need to fill the second orbit of the fluorine? 1 orbit. So valence is 1. Neon. First orbit contain 2 electron. The second orbit contain 8 electron. Neon is there, but there is no more electrons can add in the neon because already 8. The second orbit already you know the formula. The first shell should contain 2n square. 2 into 1 square is equal to 2 electrons. Second orbit 2 into 2 square. So 8 electrons should be needed. So in neon actually there is 8 electrons there. So valence electrons we can't add one more electron is there. So it is stable condition. Then sodium. Sodium first orbit 2, second orbit 8. After filling 8, one more electron is there, that is in the third orbit. Like this magnesium. First orbit 2, second orbit 8. After filling the 8, the 2 more electron is there, that is in the third orbit. Aluminium. First orbit 2, second orbit 8, third orbit 3 is there. Silica. First orbit 2, the second orbit, next 4 electrons in the third. Phosphorus. First orbit 2, second orbit 8, third orbit 5. Sulfur. First orbit 2, second orbit 8, third orbit 6 is there. Chlorine. First orbit 2, second orbit 8, third orbit is 7 is there. Then one more is the last organ. First orbit 2, second orbit 8, third orbit also 8. After that we can't add any more electrons in this organ because it is now stable in nature. So what is valency? The electrons present in the outermost shell of an atom are called valency electrons. Okay, thank you students.